This is the Chapter 2 review for polynomial equations and inequalities. 1a. We have the polynomial function x cubed plus 9x squared minus 5x plus 3, and we'd like to divide it by x minus 2. The first part of the question asks us to use the remainder theorem to find the remainder. That means we're going to find f at 2. So we put 2 in wherever x is. Once we've substituted 2 in for x, we evaluate the problem. So the remainder, when we divide that polynomial by 2, is 37. Now we'll perform the division using synthetic division. We need to arrange our synthetic division so that we're in decreasing powers of x. So 1x cubed plus 9x squared minus 5x plus 3. And we can leave the variables off. Now we're going to perform the division. So we just bring down the 1. 1 times 2 is 2. We're adding the 9 and the 2 to get 11. 2 times 11 is 22. We're adding the minus 5 with the 22 to get 17. 2 times 17 is 34. And when we add the 3 and the 34, we get 37. And that's where we're going to find our remainder, just like we did up here is our remainder. And then the rest of it will be our other functions. So when we divided x cubed by 9x squared minus 5x plus 3, we end up with x squared plus 11x plus 17 as the other factor. And then the remainder would be 37 over x minus 2. Question 2a. We have the function x to the 4 plus kx to the 3 minus 3x minus 5. And when it is divided by x minus 3, we know that the remainder is negative 10. We need to find k in this case. So we'll use the remainder theorem and substitute in f at 3. So 3 for every single x. We substituted in 3 for every single x, and now I'm going to evaluate. After simplifying, I end up with 27k plus 67. But if you recall, the remainder, when I substitute 3, is negative 10. So I need to make negative 10 equal to this expression that I have with k in it. And then I'm going to solve that. Therefore, the value of k is negative 77 over 27. In question 3. We have a polynomial function, 4x cubed minus 3x squared plus bx plus 6. And we need to find b. We know that that when this function is divided by x minus 1 and when it's divided by x plus 3, it's going to give the same remainder. The remainder theorem states that if we find p at 1 by substituting 1 in for every x, that will give us the remainder when the polynomial function is divided by x minus 1. I'm going to go ahead and do that. So the remainder when I divide p by x minus 1 is equal to 7 plus b. Now I'm going to find the remainder when p is divided by x plus 3. So I will find p and substitute in negative 3 for x. So when I substitute in negative 3 for x, I end up with negative 129 minus 3b. So the original statement said that it has the same remainder when divided by x minus 1 and when divided by x plus 3. So then this equation will equal this equation I'm going to substitute. So setting up the equation, we have something that looks like this. 7 plus b equals minus 129 minus 3b. I'm going to solve this equation for b. I'm going to continue to isolate b. I'm going to divide both sides by 4 to get my answer for b. So my final answer for b is equal to negative 34. Number 4a. The instruction was to factor. So I need to use the factor theorem to test out what might be a factor for this. In order to do that, I need to look at the last term, which is plus 6. So I'm going to use the factor theorem to test values that go into 6, like 1, 2, and 3, and -1, -2, and -3, until I find one that will give me 0 as a remainder. So I'm going to start that now. I tried f of 1 and it got a remainder of 4, so that is not a factor. I'm going to continue. When I tried -1, I did get a remainder of 0. Therefore, x plus 1 is a factor. Once we know one factor, we can use the factor theorem to set up synthetic division and find the other factor. Continuing with the synthetic division, I have -5 times -1 gives a +5 here, which makes this 6. And -1 times 6 gives me a -6 here and leaves us a 0, which is where our remainder is. So we already knew that that was going to give a remainder 0 because we know that x plus 1 is a factor. This line here translates to the other factor of x squared minus 5x plus 6. So now we can write the original polynomial as x cubed minus 4x squared plus x plus 6 is equal to x plus 1 times x squared minus 5x plus 6. We can further factor this second one. So if we further factor that, we get x plus 1, and then in these two brackets, x times x will give the x squared. Two numbers that add to give me the -5 and multiply to give me the 6 would be -3 and -2. So our final line then is this line here. Factors into those three factors. Good luck. This one looks like a messy one. 5x to the 4 plus 12x cubed minus 101x squared plus 48x plus 36, and we were asked to factor this. So again, we're going to look at the last number, and we're going to try values of x to see what will give us 0, because the remainder theorem says that if we try values of x and we get a 0, then that must be a factor. I'm going to start with f at 1. As luck would have it, trying f at 1 actually gave me a remainder of 0. So I'm going to use synthetic division to get the next step. As expected, the remainder came out to be 0, and I'm going to write the other polynomial. So the other polynomial would be 5x to the 3 plus 17x squared minus 84x minus 36. And then I'll have to repeat again to find another factor that will go into this. We found the first factor, and now we're going to use the factor theorem to find the second, third, and fourth, maybe, factors in this particular function. So I'm going to continue doing f at 2, anything that goes into 36. As you can see, f at 2 did not work, did not give me a remainder of 0. So 2 is not a factor, or x minus 2 is not a factor. I'm now going to try f at 3. Okay, as I said, when I substituted in 2, that did not work, so that was not a factor. Then I substituted in 3, and as a result, I end up with a remainder of 0, which means x minus 3 is a factor. So I'm going to use synthetic division again, only on this polynomial, in order to get the next level. As expected, we got a remainder of 0 when we divided 5x cubed plus 17x squared minus 84x minus 36. And then we ended up getting this here translates into 5x squared plus 32x plus 12, and I want to see if I can factor that any further. So 5x squared plus 32x plus 12 factors further to 5x plus 2 and x plus 6. So, looking back now on our entire problem, we found the first factor, that was x minus 1. We found the second factor, that was x minus 3. we were left with 5x squared plus 32x plus 12, and we were able to factor that even further to 5x plus 2 and x plus 6. So our final answer is totally factored. So our original question was 5x to the 4 plus 12x cubed minus 101x squared plus 48x plus 36. We got down to the final end, so that particular polynomial has factored into x minus 1 times x minus 3 times 5x plus 2 times x plus 6. This is question 5b, and the instruction was to factor. Now, when I was looking at this, and I don't know, I guess this just comes from experience, but I noticed that this 50 was twice as much as the 25, so they both have a common factor of 25 plus the x squared even. And then I also noticed that the 9 and the 18, so the 18 was double the 9. So because that's sort of the same kind of pattern, I'm going to factor by grouping. I'm going to try it anyway. If it doesn't work, I can try something else. So I'm asking myself what goes into these first two terms, 25x cubed minus 50x squared. So I'm going to take a 25x squared out to the front, and I'm left with x minus 2. I'm going to look at the second set, the second grouping, and what goes into 9x and into 18. That would be 9. I'm going to take out a minus 9 because the minus is already there. And minus 9x divided by minus 9 just gives me x. And 18 divided by minus 9 is minus 2. So we happen to luck out because we have a common factor here and here, the x minus 2. I'm going to pull that out to the front, and then what's left is my 25x squared minus 9. Then I ask myself, can this be further factored? And it can be. It even looks like a difference of squares, so I'm going to continue. So the second part was a difference of squares, so it became 5x plus 3 times 5x minus 3. So our three factors for this polynomial are x minus 2, 5x plus 3, and 5x minus 3. Okay, in number 7, we have the cubic function x cubed plus 4x squared minus 2kx plus 3. We need to find this k value so that x plus 3 is a factor. So the factor theorem says that if I find f at negative 3, and that's going to be equal to 0, so in order for it to be a factor. So then what I'm going to do is I'm going to take this negative 3, I'm going to substitute it in for x, and then find k by making it equal to 0. So on the left side, I have taken the negative 3 and put it into the function, including the k there. And then because I have to make it equal to 0, I'm continuing to make it equal to 0. So the left side is my function at negative 3, and the factor theorem says that if it's equal to 0, then that x plus 3 will be a factor. So continuing to solve, we get 12 plus 6k equals 0, 6k equals negative 12, and then finally k equals negative 2. So if k equals negative 2, then this function will have a factor of x plus 3. Thank you and good luck with your studying. I'll post some more tomorrow night.